Basically, we will touch base on 4 points: the importance of energy efficiency, the status and history of energy efficiency, what smart grids can play into the optimization of the energy use, and a review of smart grid technologies that are somehow useful. So basically, why we're talking about energy efficiency and why it's getting more traction and more attention, not only from the development bank, but also from end users. Well, one of the points that is we are, as population, we are increasing, and our consumption of energy is increasing. And the fact that energy contributes significantly large, 31% of the greenhouse gases, is somehow a key point that needs to be addressed. And of course, there is the topic of renewable energy and the energy that will have a less impact on the planet. However, if you can see on this graph that even by 2050, the sum of renewable energy will still be less than the other fuels like fossil fuels. So somehow the consumption of energy needs to be addressed as important as the integration of renewable energy. In addition to that, so far we haven't been so successful when it comes to energy optimization, because if you can see here, some countries managed to stabilize the megawatt hour per capita, but some other countries did not. And globally, if we aggregate the whole world, the megawatt hour per capita is increasing. So still, we're not doing very well on that aspect. So if you look at the world and if you look at the energy efficiency, so there have been so many things that were identified that are not helping. So for example, the energy efficiency market maturity, the credit constraint to finance energy efficiency measure, the energy subsidies in some parts of the world, the lack of awareness of users, the incentives and the policies, and the rebound effect for some countries where you get cheaper electricity, you're tempted to use energy because it's cheaper. So all of these somehow contributed to the effect that the megawatt hour per capita was not declining as anticipated. So energy efficiency is not a new topic. Actually, it started by the 70s and it was triggered by the oil crisis in the 70s. And at that time, it was mainly energy conservation. So people were advised to use less energy, the standard procedure, turn off the light when you leave the room, etc. However, there was no policy in place. But by the 80s, the policies started to be developed in certain parts of the world. And by the 90s, the appliances manufacturers started to pick up the hype and started to develop equipments that are more energy efficient, and at the same time also the certification of equipments also did help. LED lamps and all the other measures also started to be more available commercially. By the 2000, the models like the ESCO energy service companies and the performance contract, the energy performance contract, were available in the market, and somehow this assisted with the appliances to gain more traction. By 2010, we started to develop solutions for demand-side management. IoT, of course, did help. I mean, this is something that probably is being echoed in all the presentations. And now we are in the distributed energy resources management and the Internet of Energy, where the IoT dedicated for the energy and closing the loop of all the energy ecosystem is currently being present in some parts of the world. So if we look at our ecosystem of the energy ecosystem, we start by generation. We have the transmission system to convey the energy into the cities. And then within the cities, we have the distribution system reaching up to the consumer. And in each one of these levels, there are ways to optimize the use of energy. And I would like to share with you some thoughts about some of these technologies. And these technologies are mainly not measures to be used by consumers, but measures to be financed and implemented by utilities because the utilities somehow they have interest to sell energy, but they also need to contribute to the energy efficiency. So, for example, in the generation and transmission, we have the dispatching technology. In the distribution, we have technologies that I will talk about, ADMS, DRMS. Unfortunately, they are all acronyms, but we will get to that. And at the end, body consumption, there is smart metering. So dispatching, the idea here is that this technology will not only assist in reducing the energy consumption and to optimize the use of energy, but also it will allow utilities to integrate more renewable energy. And like this, we will be reducing the need to construct new fossil fuel-based power plants. And this somehow will reduce, as a consequence, the greenhouse gases effect. So here, the dispatching and the virtual power plant are somehow designed to optimize the use of power plants and allow the integration of more renewable energy, and additionally to optimize the costs associated with it. Now we go to ADMS, which is Advanced Distribution Management System. And here the idea is the way the energy is being distributed within cities is not very optimized. We have losses, we have failures that can happen within the network, and this somehow affects the reliance of the energy, and also affects because we have line losses. So having systems in place by utilities to optimize the distribution of the network and to have the energy more efficiently distributed to consumer is somehow going to have an impact. In addition to that, demand response management system is a system that is intended to respond to the availability of renewable energy and shift certain loads by consumer in order to reduce the reliance on fossil fuel-based power plants. And like this, we'll be able to do more with less, which is more renewable energy. And demand response management system is a complex system that can be used not only for large facilities, however, it can be used by a normal consumer. And in that case, an aggregator is needed in order to sum up the consumptions of all commercial and residential consumer and provide some flexibility to shift the loads in order to not have a peak that needs to be addressed by fossil fuel-based power plants. Distributed energy resources, which is a very interesting topic, it started to be a very important backbone within the utilities, which is the fact that a lot of consumers now are interested, and there is the financial facility and the technical availability of solar PV that are installed on rooftop. However, the users are not consuming the whole power that is generated, and the idea is to create a pool of energy that is used within the city or within a country to share this renewable energy within the city so that we can reduce the reliance on fossil power plants. And last but not least, smart metering, where the users have a meter that is somehow connected with the power system, and it indicates the price real time in order to incentivize the users to reduce their consumption by increasing the rate of kilowatt hour or increasing it based on the availability of renewable energy. So all of these are somehow, and this is the architecture of the smart metering, but yeah, I mean, I don't think we'll have the time. And somehow all of it together will affect the fact that we can do more with energy, we can optimize the energy use and be able to integrate more renewable energy. I will take advantage of the great minds that are available in the room, and I will close here. And since I will not be able in the question and answer session, so maybe we can change a little bit the structure and open the floor for questions.